So now, just to sort of conclude this week, we understand that the ratios, if we use a story like this, then it doesn't go against the sense of fairness that children have, that one person gets about a liter of water, because otherwise if you say one person gets 2 chocolate, another person gets 3 chocolate, it feels a little unfair. And so when you have done the ratio and you have said that if you pick any 2 ratio that they are in proportion, then you also have the multiplication sort of rule, which also makes sense. And if you look at it in terms of ratios, you know that the common, let's say, number of days, for example, cancels out, and you will get that 2 by 3 is equal to 36 by 54. What is more important is that if we did not know 2 by 3, so let's say we did not know this, right? And then you say, okay, someday, and I don't know what it was, but at some day I got these 52 to 64 is to 78. Now, tell me what was the original. How many people were there in one house and how many people were there in the other house? And you're not telling them, they are not telling the number of days this has been. So in that case, you would do what you would do for finding out the common factors and getting rid of them, right? So if you did the first steps towards GCD, then you know, okay, 2 is common. So I say, all right, so 2 is a common factor. This one will become 26. This one will become, okay, you can use same color. Okay, so that's 26 and 39. And then you say, okay, this is 13 tables. Well, I hope we know it's 13 tables. And then, so you do 13, and then you get your code 2 is to 3. So this is one way of getting to the, what is the base ratio, what is the smallest ratio that you can start with, and that's 2 is to 3. So that's how we get these two. And if you can do it, of course, for any of these numbers in which you pull out the common factor, and in our story we have been calling this the number of days, right? So that's one way to go about figuring out what is the base ratio, which can be used to determine any other ratio. So if you wanted this as a starting ratio and to say what will happen if this was just 4, like in the question that's been asked, that if you have a certain number of beads and then you want to have the same ratio, but you want smaller number of beads, what are all the ratios possible? Then you need to get to the base and then build up from there. So yeah, so this is the way to get to the base. So in that example, there are red beads and there are blue beads, and it makes a necklace, and there's even a picture given, and so it turns out that there are 35 red beads and there are 30 blue beads, and the question is, well, I want to make a smaller necklace. How many possibilities are there? So the first step is to really find what is the base ratio, right? So I say, okay, it's an obvious question, but anyway, 30, and I take common. So I get my 7 is to 6, right? So this is, you can't have any more factors. So the base is 7 is to 6. And we know that if you were thinking about, okay, a story of number of people, so it's 7 is to 6 is the first day. And we are basically saying that to get till here, there are 5 days, right? 5, because 7 5s are 35. So you have 7 1s are, then you have 7 2s are, so you'll get 14, then you have 7 3s are, which is 21, and then you have 7 4s are, which is 28, and then of course 35. So you have 4 combinations, and if you wanted the equivalent of them, you can also have those 12, 18, 24. So that's an example of using this ratio proportion and figuring out what is the base ratio and going forward with that. So what is the alternative to the unitary? That's what I had been asked. So what does the unitary question kind of mean? It says that of 1 dozen balls, so let's say 12 balls, right, cost 180 rupees. So 5 balls will cost how many rupees, right? That's the question. So if the number of balls cost is the same, that's like 1 person how much they consume, then you could have, if you really prefer ratios to unitary or something, you can say, okay, 12:5, the number of balls has a certain ratio and the money has to have the same ratio, and that is 1:1 what? So we have seen these questions, right? So you have to do, okay, 180 is there, 180 divided by 12. In our old story, 180 is consumed. That's equivalent to number of days, let's say. And so this is 6 tables, 6 2s are 6 3s are 15. So in 15 days, what would this have been? So this is like 15 times 5. So if you prefer looking at it like this, you can also solve it like this. But essentially what you are doing is, of course, finding out the cost of one ball, which is 15 rupees, and finding out how much 5 balls will cost. But if you prefer doing it this way, where you have 2 different colors and you systematically do one color and then do the other, you can also write it like this. Ratios are dimensionless quantities, so these two should have the same dimension, so you can cancel it off or remove it. So here it was number of balls and here it was number of rupees. Okay, another question of 3 units of power is in 40 minutes. How many units of power in 2 hours? 2 hours is 120 minutes. So that is 3 is to 40 is what is to 120. Now because the number is becoming smaller, the first thing you should have done is, okay, 40 and 120. I remove the common factors and find out what is the core. Right? So this is of course 4, so I'll take 40. So I get the core is 1:3, and so if this was 3, then I have to multiply both of them by 3. So this one will become 3 times 3, which is 9. So if you prefer doing it like this, it's also possible to do it, but the principle is the same. But perhaps you find it easier to do it like this, you can do it like this. So in conclusion, if you are an alternative to this unitary way of unitary method, is to look at it as the ratios that we have been used to, and if you've played enough with it and you can predict them, then you can also do this.